Hi, I'm Yannis Kanellopoulos and I'm a senior consultant at Software Improvement Group. I'm also leading the development of the Training on Software Maintainability initiative. This training stems from our deep belief that software is the DNA of our society. Working for more than 15 years with large corporations around the world in different sectors like finance, logistics, insurance, healthcare, or high-tech, we experienced what it means to have bad or unmaintainable software. Based on those experiences, we learned a thing or two about maintainability, and today we are in the leading position to share this knowledge with software developers on a global scale. This series of training videos delivered by my good colleague Željko Obrenović is part of this initiative. For more information about our services and the training program, you can visit sig.eu. If you really like the books and the training videos, we would like to inform you that this can lead to the professional title of Certified Quality Software Developer. For more information about how you can get more help mastering this, you can visit our website.
Hello, I'm Željko Obrenović, and today we are going to talk about building maintainable software. We're going to talk about what software maintainability is, why it is important, and we are going to present you a number of guidelines, and we are going to show you a number of code examples. Before we dig into details, let's first say a few things about us and what are we doing and how we came up to these guidelines. We are Software Improvement Group, and I'm a consultant working at Software Improvement Group. At my role, I combine elements and work in the roles of analyst, analyzing software system, software developer, consultant, researcher, and also a teacher. What is Software Improvement Group? We are a consultancy firm which is specialized in analyzing cost, quality, and risks related to software systems. We have strong links to academic world, and we are founded in 2000 as a spin-off of Dutch National Center for Computer Science and Mathematics in Amsterdam, CWI. And what we do, we provide factual advice based about software quality based on automated tools for source code analysis, and we are building these tools as well. And we, in past 15 years, have analyzed and measured quite a few of technologies in many different types of systems. One of our key values or key skills is automatically analyzing software systems, and in past 15 years we've seen quite a few of them. So we analyzed more than 1,500 different software systems, and not just one version of them, but in total more than 40,000 different versions of these systems. We've seen more than 100 different programming languages, starting from some old languages such as COBOL or Fortran, and you also analyzing contemporary languages such as C#, Java, Scala. In total, we've seen more than 7 billion lines of code, and we are continuously analyzing and monitoring a huge number of these systems, analyzing about 27 million lines of code each week. And in this series of training videos, we are going to bring you and present you generalization of some of the lessons learned from this software analysis. These training videos are going to be centered around 10 guidelines for building maintainable software, and they are based on our experience and analysis. And more detail about these guidelines you can also find in forthcoming book called Building Maintainable Software. So there are more details and more background information about these guidelines. The goal of this training video is to help you first to get full understanding about these 10 guidelines and motivation for them, and also to give you some practical skills about how to apply these guidelines. And what are we going to cover in these videos? There are going to be a number of topics. First, we are going to briefly talk about what is maintainability, what is software maintainability, and how it differs from other types of maintainability. Then we are going to present each of the guidelines in more details. We are first going to focus on 4 low-level guidelines, on the unit level, what we call, and then explain what these guidelines are, present background, and give you some live coding example for each of them. After them, we are also going to make one bigger exercise of refactoring, which will cover several of these low-level guidelines in one example. We will follow with 4 high-level guidelines, which apply on the kind of more architectural level. And again, for each of them provide explanation, some examples, case studies, and then follow again with one bigger refactoring exercise where we cover several of these high-level guidelines. In addition to these guidelines that we explicitly cover in separate training videos, we are going also to introduce and explain you 2 process guidelines about unit testing, or about automatic testing, and about writing clean code. These guidelines won't be presented in separate videos, but in many of the videos that we are going to discuss, we are going to talk about these 2 topics. So that was briefly introduction, and now we are going to continue presenting some more details about what software maintainability is. In this training video, we are going to explain and talk about maintainability. We're going to define and explain what software maintainability is, and also to say something about how you can measure software maintainability. Now, you've probably heard and you probably deal daily with software maintenance. And software maintenance is an interesting term because term maintenance has completely different meaning in normal world compared to world of software development. In kind of ordinary maintenance process, such as hardware maintenance, maintenance means returning some item to its original state. So if something is broken, you need to fix it. If something is can be old, you need to repaint something. That's not the meaning of the word that we use it in software maintenance. In software maintenance, we are moving an item from its original state. Each time when we do software maintenance, we are changing a piece of software and making it different from what it was originally. And in software maintenance, we cover a number of tasks and topics. So it can be something related to bug fixes, but also covering up for hardware errors. We can do software maintenance to improve functional requirements or to add new functionality, or to make our system perform better. We can change system to provide backward compatibility. We can do maintenance to update algorithm or to create new user interface access method. We can do also a number of cosmetic as well as other changes. What's interesting about software maintenance is, as also said by many of other authors, is that in software, adding a 6-line automobile expressway to a railroad bridge is considered maintenance. And it would be particularly valuable if you could do it without stopping the train traffic. And that's exactly the topic and issue that we are going to discuss here. How can you build software that can enable you to do these radical changes through all of your time? When we talk about software maintenance, we normally talk about 4 different types of software maintenance: corrective, adaptive, perfective, and preventive. Corrective maintenance means correcting some discovered problem, for example, fixing bugs. Adaptive maintenance means adapting to some changes to the environment. For example, you need to adapt your software to new hardware, to new version of database, or to changes in laws. Perfective maintenance means improving performance or improving generally maintainability state of your application. For example, you may update a new database driver which works better with the database that you're using. And preventive maintenance means kind of working preventively to detect and correct latent faults before they actually cause some damage. For example, you may use some old libraries that have some vulnerabilities and you want to replace them before they actually cause problems. Software maintenance also has its clear relation to business and business growth. Many studies have shown that when you look at the cost of the software system, most of these costs occur after initial investment, so after you made first release or first successful version, then you enter in this kind of operation or sometimes called maintenance mode, and most of the costs that you have for a software system come from these recurring costs in this operations mode. And depending how well you write your software, how easy your software to maintain, these costs can be significantly higher or lower. And also through these guidelines, we want also to give you skills to write software that can cost less in long run. When we present guidelines in follow-up videos, we are going to talk about concrete, detailed actions that you can do on your software. But behind each of these actions, there are a few general principles, or what we call axioms, that we have applied. First is, when we talk about maintainable software in business, sustainable business needs maintainable software. So if you want to have software that follows and supports your business, that drives your business, that has to be software that's easy to maintain. Second is that maintainable software is software that is small, simple, and flexible. In other words, it's not some magic, complex solution that you need to write maintainable software. It's applying basic principles all of the time. And the third aspect is that maintainability is measurable. So it's not something that you do based on your intuition. There are quite a few methods and tools that you can use to get concrete measurements about what is maintainability of your software. And measuring maintainability is one of the key elements for our guidelines, and our guidelines are defined as the generalizations of number of measurements that we've been applying on software systems. In general, we can talk about three types of measurements that are relevant for maintainability. First is size, for example, lines of code, because bigger elements require always more time and effort to maintain. The second is complexity, for example, the complexity of control flow in your application. And the third is coupling, or degree of interdependence among elements in your system. What we also noticed by doing these measurements is that these measurements and changes in values that we see are not always linear, and there are normally some places or some points when things go better or worse. So what we often see for many of the elements that we measure, that they follow the similar pattern. So if you keep your system small, simple, or with low coupling, you can go a long way. Normally, you can easily maintain it. Once when you reach a particular level of size, complexity, or coupling, then it gets more difficult to maintain your software, and the speed with which your system gets more complicated, bigger, or highly coupled increases. And after some time, after you reach some point, there's no way back. Then your system is so big, complex, and highly coupled that it's very difficult to do something to maintain it or change it. And in essence, our guidelines are kind of road signs that tell you, look, now we are approaching a point where things can get complicated, where you may not be able to continue if you go that way. So now it's time to try to do something about and go back to safe zone. And basically our guidelines are like that. So for each of the measures, we identify this kind of tipping point when you need to go back to keep your software under your control. To summarize, so in this section, we talked about software maintenance. We explained that it differs a lot from standard definition of maintenance, which normally means returning an item to original state. In software maintenance, we are moving an item from its original state, and we can do it on many different ways, doing corrective, adaptive, perfective, or preventive maintenance. We also explain that there are a few principles that apply to maintainability and also that are the basis for our guidelines. That is that sustainable business needs maintainable software. That is that maintainability software is software that is small, simple, and flexible. And the last is that maintainability is something that can be measured. In this training video, we are going to show you a few basic guiding principles that we applied in each of these guidelines. We are also going to discuss different levels and how you can look at your software system, and also explain to you that these guidelines that we have apply on different levels. There are three basic principles that we follow in each of our guidelines. First is that maintainability benefits most from adhering to simple guidelines all the time by everyone. So every individual contribution counts. It means that maintainability is not something that you can solve by some magic solution or that one heroic person can do without help from others. That's something that has to be a team effort in a long time. The second is that maintainability is not an afterthought, but should be addressed from the very beginning of a development project. So this separation of initial development and maintenance mode should not exist. You start to maintain your code from the very beginning. And the third is that perfection is impossible, so you cannot follow all the guidelines all the time, but you should be aware that the more of your system complies with the guideline, the better. I'm going to elaborate a little bit more about this third point. So what you see here are visualizations of two software systems where we present with blocks what we call units of code. These units are, depending on language you use, things like methods, functions. Each of the block is one of these units, methods, or functions. The size of these blocks tells you how many lines of code do you have in each block. And the color of this block tells you how complex are these blocks. So what is the complexity of control flow within them. Now, without going into detail, you can see here two completely different systems in terms of maintainability. So none of them is perfect. All of them have simple as well as complex parts. But you see there is a difference in balance. On the left side, you see something that we call sustainable. Yes, you have few very complex units. Yes, some of them are long. But most of your code is simple, and that's basically what you get when you try to comply to guidelines all the time. So that's something that you can keep under your control, because most of the time you're working on small pieces, simple pieces of code. On the right-hand side is a system that we see as unsustainable, because if you count the lines of code, you see that most of these lines of code are in very big, very complex units. That means that almost every change that you need to do will be made in one of these complex parts, and that's something that's very difficult to maintain. So that's basically what we want to say. Perfection is impossible, but the more elements of your code you have compliant to the guidelines, the better. You can look at the software system at many different ways and many different levels, and our guidelines are also coupled to these levels. So normally when you start to write your system, you work what we call a unit level. So you write some expressions, you write some statements, and you group these statements into what we call units. Depending on language, this unit can be something like a method, procedure, function, or subroutine. We use this more abstract definition of unit in order to make our guidelines apply to many languages. And this also picture shows you how you can apply the guidelines to languages that are different from the example that we are going to show you. So units are the first level that we see in a system, and there are few guidelines that we have for this level. These units then are normally further grouped in what we call modules. So that can be a file, that can be a class with multiple methods, that can be some script. And these modules can then further be grouped into some high-level components that can be top-level directory, a package, a namespace, a Maven submodule, or Visual Studio solution. So you have multiple of these components. And then these components form together a whole system. It's basically code-based, maintained by a team of developers. And our guidelines address always one of these four levels. Here's briefly an overview of all these 10 guidelines, as well as their relation to levels that we described on the previous slide. As I already said, for each of these guidelines, we are going to have a separate training video, but it's just an overview how they relate to our view on software system. So first we have 3 guidelines that relate to unit level, and that's to keep units short, to keep units simple, and to keep unit interfaces small. Then we have guidelines that is basically applied for a whole system, so that you write code once or to avoid writing duplicated pieces of code. The 5th guideline is to carefully separate concerns into separate modules. And then there are 2 guidelines that apply on a component level. And the first is to couple architecture components loosely. And the second is to keep architecture components balanced. Overall, there is also another guideline that says that you should try to keep your code base as small as possible. In addition to these 8 guidelines that we are going to cover with separate videos, we also have 2 kind of more process-related guidelines, and that is to automate tests and to write clean code that apply to everything you do in your system. So this is briefly overview of our guidelines. So we presented you the main principles that we use behind our guidelines. We presented you different levels of how you can look at the software system and explained to you that our guidelines are related to one of these different levels. In next video, we are now going to zoom in the first of these guidelines and explain to you how to write short units and why are they important for maintainability. We are going to proceed with our next guideline for writing maintainable code, and that's to keep units of code simple. Again, we are going to talk about on which level this guideline works, define this guideline, explain how you can measure it, and give you examples of compliant and non-compliant code. As we already explained, we look at the system at 4 different levels: unit, module, component, and system. And the guideline for simple units applies, in this case, a unit level, again, methods, procedures, functions. Examples that I'm going to show you are again in Java, but this rule applies to all other languages. So let's look at the definition of this guideline to write simple units of code. So what you should do is to limit the number of branch points in each of your unit to 4. How you can achieve it? So first, by splitting complex unit into simpler ones. So if you already have a unit with more than 4 branch points, you can create multiple smaller ones, each of which has less branch points. And the second approach is to build a habit to actually from start write simple units of code, so basically to avoid writing complex units. Why is this guideline important for maintainability? First, because it's easier to test your units. So if you have less branch points, you need less test cases to fully test your unit. They're much easier to understand because each branch point requires some understanding of some logic and testing. And also they're much easier to modify because there are less cases that you need to understand. This also has a number of positive effects on other guidelines. So less complex units are normally also smaller ones. And also less complex units normally require less parameters. So in that case, your unit interfacing is normally smaller. How can you measure complexity of your units? So how can you measure simplicity of your units? For this one, we apply methods which is called counting of cyclomatic complexity, and you also sometimes may come across the term McCabe index. So what we do is to look at the codes and look at every branch point in your code. That can be an if statement, case statement, for while loops, as well as any logical operand such as AND of OR. So all of them are counted. And then to this count, we also add 1 because method that does not have any of these branch point have still 1 route through which you go. And basically, by this counting, we count a number of diverse routes or paths that you can have through your unit. So this is one example of a code that we also see in the previous section. So it has 15 lines of code. And you can see here there are 2 branch points. So there's while, and within this while there are 4. So according to our rule how to measure it, it counts as 2, and then we add 1 for all the method. So this unit has complexity of 3, and this is a unit that is compliant to our guidelines. Here we again see 2 examples from existing code. In this case, it's a Jenkins open source project. Both of these units, in this case Java methods, are compliant to our guidelines. The first one has 3 branch points, and the second has 4 branch points. As you can see, again, this size as well as complexity makes it quite easy to understand what these units are doing, because these tests are clear. So in this first case, we'll have return some value, go for some queries, and compare labels with the value that we received, or kind of the value that we used to get other parts. And second case, we have 1 more branch point, but they are relatively simple things to do, like comparing if the value type is null, or if there is nothing given in the parameters, with then some loop and test in between. So this is something that normally you can easily understand and test. Again, we have the same example that we showed in previous section, which is also not compliant with our rule to write long units of code. And in this case, this is also a unit that is not simple because it has more than 4 branch points. In this case, 5. And the reason why this method is complex is, again, because it encapsulates quite a few different responsibilities to preparing some queries, to making connections to database, to processing each item as well as summary of these items. And each of these processing and responsibilities requires some logic and some branching points. How would be better for maintainability? It would be better if each of these responsibilities and branching point are actually splitted in separate units so that each unit has just a few tests or branches to do. What it also makes complicated if you have all these branching points in one unit is how to test all this. So basically, if you want to test each branching point, you always need to call and prepare whole methods, which makes your ability to properly test and to maintain your tests actually lower. So let's summarize this guideline. So here talk about second guideline to write simple units of code. So what you should do is to limit the number of branch points in each of your units to 4. How you can do it? There are 2 ways. One is to split already complex units into simpler ones, so that you have units that are distributing this branch point, each of them having less than 4, or to build a habit to write from the beginning simple units or to avoid writing complex units. Why is this important for maintainability? It's important because simple units are much easier to test, much easier to understand, and easier to modify. In next training video, we are also going to go to live coding session and show you how to apply this guideline in practice. We have one more live coding session, and here we are going to illustrate the working of our guideline to write simple units in practice. Again, as for most of the live coding sessions, we are going to look at the description, what we should do, a ticket in our Jira issue tracking system, analyze existing code, because that's our starting point and our goal is to change this code, and change this existing code to implement new functionality according to our ticket, then run existing tests to check if we have not broken the existing functionality, and add new tests to test new functionality. Then we're going to go back to the original code to see if our guideline, if our implementation does not validate maintainability guidelines, and if it does, we're going to refactor it. And also then look for some opportunities to clean the code or to make it even simpler or cleaner. So what we need to do in this session, so we have a new ticket which is called filter valid O'Reilly's ISBN numbers from a list of ISBN numbers. So if you remember in previous section, in previous live coding exercise, we added extended functionality to validate ISBN numbers from ability to validate only 10-digit numbers to ability to validate 10-digit as well as 13-digit numbers. And in this session, we also need to add new functionality then to return from a list of ISBN numbers only ISBN numbers that are books being produced by O'Reilly, and then also to validate if these ISBN numbers are valid. So now we are in our development environment, and let's start to do our work on implementing our ticket. So our goal is to create a new functionality that, given a list of ISBN numbers, will return only a list of ISBN numbers from O'Reilly as a publisher. Our starting point will be existing code, the code that we actually extend in the previous live coding session. So that's ISBN utils class. So here we have the function to test validity of ISBN 10 and 13-digit numbers. And we also have some associated tests that some inherited from previous development team, and some of them wrote in the previous live coding session. So before we start to change anything, let's first see if all these tests are running and if our code is functional. So all tests have passed. So basically, currently we have functionally stable point. In addition to this code and tests, we also have a check style configuration for our check style analysis tool. And in this case, we are going to focus on limiting the number of branch points to 4, or in terms of cyclomatic complexity, trying to see if our units have cyclomatic complexity which is lower than 5. Remember that we define cyclomatic complexity as a number of branch points plus 1. This is kind of default path that you have in your unit. So let's go back to our starting point and see how this code complies. So we see that checkstyle has found no problem, meaning that currently this code complies to all maintainability guidelines. So the units are short, units are simple. So our goal is to create a new functionality. In this case, we are actually going to add a new method to our ISBN utils class. This method should return a list of strings, list of ISBN numbers. And I'm going to call this method, let me first import the proper class. So I'm going to use util list class, Java util list class, standard class. I'm going to call this method get ISBNs from O'Reilly. And I'm going to receive as a parameter to this method a list of ISBN numbers that can be from O'Reilly, but can also be from other publishers. And it's also a list of strings. I'm going to call this parameter ISBN list. So what this method should do is then go through this list, see if the item on the list is from O'Reilly publisher, and add this and return only this part. So first I'm going to create a skeleton of this method. So I'm going to create one result variable. As a list of strings and initialize it with a new array string. So currently I have empty list, and I'm going to return this result list. In between, I now need to add logic that will then go through the original list, check if item on the list is from O'Reilly publisher, and then add this list to the result. So in that case, what I need to do is to create for loop. And for each ISBN number from the list, go for it. And now we have a tricky part, and that's basically how to identify if this ISBN number is from O'Reilly. So I already did some research and talked to original people that make a ticket. So what I learned is that this ISBN number list is going to give me ISBN number separated by hyphen. So the number of like 1, 2, 3, hyphen 4, 5, 6. And that each of these sections separated by hyphen have some different meaning. So, and one of these sections is actually the code from publisher. And I also learned that for O'Reilly there are 2 of these codes. So what I need to do is I need to split the ISBN number that I have currently analyzing, create a list, array of strings. I'm going to create new variable parts, which is a string array, by splitting ISBN number. I'm going to split it around hyphen. So what I'm going to get here is now, instead of having one string with numbers separated by hyphen, I'm going to get string parts with number of different elements. What I also learned is that, similar to our previous exercise and difference between ISBN 10 and ISBN 13 numbers, I'm going to have 2 cases of ISBN numbers in this list. One case having one case where we have 4 elements in this our parts array, and that basically reflects our ISBN 10 numbers, and one case where I'm going to have 5 elements in our parts array, and this reflects ISBN 13 numbers. So then what I need to do first is to check which of these cases I'm in. So if number of parts.length equals 4, then I'm in ISBN 10-digit numbers. Else, I need to check if I have 5 elements. Then I'm in a 13-digit section. And in any other case, this is not a valid or not a properly formatted ISBN number, so I'm just going to ignore it and continue through our loop. And now I need to write code for each of these sections. So what I learned is that in each of these parts, one part dedicates to ID or number of a publisher. In case of 10-digit ISBN numbers, I learned that these parts have the following meaning, and I'm going to create a separate variable for each part of this, or each of these elements in this parts list. So first I learned is that the first element is actually a group ID. So parts 0. The second element is actually code of publisher. The third element is title, or title code. And a fourth element is a check digit number. So this is now what I get. So basically, I have given a proper name to each of these parts. And what I now need to check is if this publisher code is one of the codes that is being assigned to O'Reilly. And I learned that there are two of these codes. So one is 596 and the other is 449. So I'm going to just write a code to saying also if publisher equals 596 or publisher equals 449, then that's O'Reilly. So in this case, I need to add this ISBN number to the list. But before that, according to our ticket, I also still need to check if the ISBN number is valid. So what I'm going to do is now do this check. There's only one trick here. The trick is that I have ISBN list, and in this ISBN list, I have ISBN numbers that are being given with a hyphen. But our logic for validating ISBN numbers requires full numbers without these hyphens. So what I'm going to first do, I'm going to clean up our number, ISBN number from list to get just numbers without hyphen, to create temporary variable for this by basically replacing hyphen with empty string. And then I'm going to check if this is a valid ISBN 10 number. So we are now in, because this has 4 parts, we are now in ISBN 10 numbers. So I'm going to say if, and here I'm going to reuse existing functionality for testing ISBN 10 numbers. So saying if is valid ISBN 10, and I'm going to give this ISBN number. So in that case, I'm now sure, so the publisher is O'Reilly, so this is tested, gives me that, and this is a valid number, so all I have to do is now add this to result list. And I'm going to add the original, the ISBN number in original form, so not the ISBN number clean with hyphens, but ISBN number that keeps these hyphens. So this is basically the first part of our code. And now I need to do similar for the second part. In that case, I basically learned that this logic is quite simpler. There is just slight difference in where each of these variables is being positioned. So what I'm going to do, I'm going to copy-paste this code, paste it in this part, and just adapt it based on ISBN 13-digit parts. So what I learned, the difference is primarily in the place where these elements are. So in ISBN 13 declaration, so where we have 5 elements. I learned that the group part is actually not the first but second element. Publisher is a third element. Title is 4th element, and check digit is 5th element. So that's the difference. So now the publisher is this third part. I still need to do the same logic. So I check if this publisher is one of the O'Reilly's numbers. If it is, I now need to check if this is valid. Again, I need to replace hyphen with empty string. In this case, I need to validate not if this is ISBN 10, but if this is valid ISBN 30 number. So this is our initial implementation. So what we did is we created a new method which receives a list of ISBN numbers separated by hyphen. We created an empty result list, and then we created a loop. In this loop, then we went through the list of ISBN numbers. For each ISBN number, we split it in parts and then checked which special case we have. If it's 4-part ISBN number, then we're talking about ISBN 10 numbers. And in this case, I know the publisher is the second element here, and I check if this publisher equals one of the codes for O'Reilly. And if I have 5 elements, then I'm dealing with ISBN 30 numbers. So I know that their publisher is the third element. And again, I need to check if this publisher equals one of the O'Reilly's numbers, and then check if this ISBN 30 ISBN number is valid ISBN 13 number. In both cases, if this test pass, I add this to the list. And then in any other case, I just continue looping, ignoring things that are not formatted as 4 or 5-part ISBN numbers. And then when I finish this loop, I return the result list. Now, let's see if this is working. And the best way to do this is actually now to write some tests that actually are going to test if what this implementation here shows actually does what we think it should do. So I'm going to go to ISBN util test class. Here, we have not been changing any of the other methods, but still I can first rerun the test to see that existing functionality is still working, so that's fine. And I'm going down now to add few more new tests related to our new method. And again, similar to testing of valid ISBN numbers, I'm going to add one method that tests kind of positive case, so the test if the method returns O'Reilly's book from a list of O'Reilly's books, and then the second one where I also have a list without O'Reilly's books or with some books that are not from O'Reilly, and to check if these books are properly handled. So I'm going to start a new test. Call this test O'Reilly ISBNs. And then I'm going to create 2 lists. First, we're going to be input. And create this as a new array list. And then convert a kind of as list of strings. So I already from a ticket have some examples of what are the proper O'Reilly and numbers. So there are 2 of them that I'm going to use here. So one is 978 hyphen 1 hyphen 449 hyphen 39368 hyphen 7. So here you see we are dealing with a 5-part ISBN number. So here the third element is actually the publisher code, and the others are other elements. And I'm also going to add one 4-part number, 0 hyphen 596 hyphen 00309 hyphen 9. So this is our input. So what we now need to create is an output, and this will going to be, again, a list of strings, in this case, result of calling our new method. And this is, again, ISBN utils dot, and I should have this method. I don't think this method here, so there's probably something I haven't done good in implementation, so I'm going to go back. Yeah, the reason why I'm not seeing this is because I want to create utility function, static function, but I created it as a non-static function. So in this case, I cannot call it just by via the name of the class. So I'm going to fix this and make this method static. And back to tests. Now I see this method visible. I say, okay, this output equals the result of get ISBNs from O'Reilly, and where I use input as a parameter. So now I have the basic functionality, I have input, get output, and now I need to do a few assertions to make sure that this method works as it should. So in this case, because both of these numbers are one of the ISBN numbers, I should get output that is more or less identical or practically identical to the input. So first I'm going to assert that the number of items that I get in output equals the number of items that I have in input. And then I'm also going to compare that each of the items that I get in output is the same as the one that I have in the input. So first I want to say that the first item from output is the same as the first item in output. And I'm also going to check this for a second item. So this is our test. I create input, get output, and then I compare that the input list is the same size as output list and that both items in output are the same as an input. So let me run this test. So this test passed. So this is basically we get our proper functionality running. So this is the first safety net that we created, and also first proof that what we've implemented is functionally correct. Just to make sure, it's also good to have a separate test case that tests when you have a list which is not only from O'Reilly, so avoid having a method that always returns the same list. So I'm going to create a new test and call it test different ISBNs. So basically I'm going to test if I have situations where I have O'Reillys as well as non-O'Reillys ISBNs. Again, I'm going to create input variable list as a new array list, again converting it from a list of literals. And I'm going to give you two examples. One is from O'Reilly, so basically the same as the one from positive example. But I'm also going to type another number that I know is not from O'Reilly. In this case, it's going to be 0, 5, 9, 6, 0, 0, 3, 0, 9, 9. I'm going to change some issues here. Again, create output in the same way. The result of ISBN utils.get ISBN from O'Reilly function. But now my output should be different from the output from the original test, because now I have one number which is O'Reilly number and the other one which is not. So in this case, I should have a list which is not having not two elements but one. So I'm first going to assert that that I have only one element in the output. And then I can also add assertion to check if this element is the one that I give it. So basically, if the first element in input is the same as the first element in output. Now let me run this test. So you see all tests have passed, so this test also passed, meaning that we also have this properly tested that is returning only O'Reilly's numbers and not returning the numbers that are not O'Reilly's, because this code is different. And we also tested that this is working properly when we have also few of these numbers. So now basically we finished the functionality part of our exercise, or kind of the parts. We have code that actually works or does what it should do according to our specification. Now let's go to code and see if our implementation is compliant to the maintainability guidelines. And I'm going to run our check style analysis. And I see here that now I get new method, which is not only pretty long, but has cyclomatic complexity of 10, which is basically twice as much as our guidelines would recommend. So basically you have, in this case, 9 branch points and 1 default that we count as well. So now let's do something about it. What we need to do is simplify or refactor this. And approach that we are going to use here is very similar to the one that we are using for long units. So we are going to split this complex long unit into a few smaller ones. But before that, I'm going to also look a little bit of code and see maybe there are some other things I can do. And one thing that I noticed here, for example, is that there is the same check for O'Reilly publisher. So before I actually do refactoring of bigger chunks of code, let me first encapsulate this piece of code, this check for publisher, in a separate method and give it a name that says what this is actually doing. So I'm going again to do refactoring, extract this expression into a method. And what this is actually doing is saying is this publisher O'Reilly? And now, instead of having kind of cryptic expression here, I'm going to have nice call to a method that clearly says what it does. It's also good when you use contemporary editor is that if you have multiple places where you have the same logic, editor will recognize it and offer you ability to replace this code with the, again, calling of a new method. And I'm going to accept this because this is the same check. So what I now have is I reduced a little bit of complexity of my code because I reduced the number of branch points, so I don't have any more ORs here. So if I run analysis, you see now the cyclomatic complexity is 8 instead of 10. And I did it by abstracting some of the complex part and separate utility function, which is also, in this case, more easy to understand what it does. But I'm still not done because this method is still complex. So what I'm going to do is I'm also going to extract pieces of code that are relevant for different parts of processing. So I'm going to create a separate method that handles the case of ISBN 10 numbers, or ISBNs that have 4 parts. And I'm going to select this part, go to refactoring, select extract method, and then just here get this new method and call it get ISBN 10s from O'Reilly. This is a method that gets me into, it populates in the list only ISBN 10 numbers. And I'm going to do the same, the second part, extract this in a separate method. And call this get ISBN 13s from O'Reilly. So what we now get is, instead of having one big and complex unit, I split this unit in a few smaller ones. First, extracting some checks, one check into a separate unit to check if publisher is O'Reilly, and adding 2 more methods that are handling separate cases, one handling 13-digit ISBN numbers from O'Reilly, and the other 10-digit numbers. from O'Reilly. Now, because every refactoring is changed, so let's first go back to tests to see if this is still working. So you see all tests have passed, so basically our refactoring, while has introduced quite significant changes to code, has not changed functionality, so that's nice. Now we can also see how it deals in terms of our guidelines. You see check styles have found no problem. So what we now have, instead of one complex and big unit, we have a number of smaller ones, but each of these units is fully compliant to our guidelines. So now we finished more or less most of the work. So we created a method that does what it should do, and we tested it, and we also created it according to our guidelines. But still, let's spend some time to see, is there something else that we can do with this code to make it more clean? The first thing that I noticed here is that there are a few variables that are actually being created, but are not being used, because in both of these methods, I only need to get publisher information, so I don't need information about group title and check this. So I'm going to remove all of these variable declarations that are not being used. And now I get 3 lines smaller code. I'm going to do the same in the second method. So you see there are no compile warnings, so these variables are not being used anywhere, so they are not being affected. So that's one thing that I'm going to do. And second is also the fact that in this method is O'Reilly publisher, I actually have hard-coded string constants, some kind of magic numbers, and that's also not a good practice. So what I'm going to do, instead of having it here, I'm going to extract them into constants. Again, do refactoring, and extract this in content, and going to call it O'Reilly publisher code 1. And I'm going to extract this in another constant, calling this O'Reilly publisher code 2. Now I don't have any more magic constants into this code directly hard-coded. Instead of that, I have clearly defined constants, Java constants, which also are easier to understand and maintain. Again, let me see if I have not affected our guidelines. No, so this code is fully compliant. Let me again see if this refactoring have not affected our tests. No, the tests are all passed. So now we're done with our exercise. So we started with the code that we inherited from the previous exercise. So that was ISBN util that was checking validity of ISBN 10 or 13 numbers. We get a task to extend it by adding a new functionality that returns ISBN numbers that are only from O'Reilly. In that case, we get ISBN list, which contain hyphen-separated digital codes, and we return the result list of these numbers that are having O'Reilly as a publisher. We wrote some tests, make sure that this worked properly, but we also see that that was much more complex than our guidelines would allow. And then we do a few refactorings. So first, to reduce complexity, so we extracted different parts in separate methods, as well as some of the tests in the separate parts. So we basically distributed branching points in 3 smaller units instead of having them in 1, and then have used 4 units to just call. And then we also looked for a few opportunities to make our code cleaner, so removing unused variables and extracting magic constant into proper Java constants. So with this, we finished our second coding live coding exercise. And in next video training, we are going to continue with our third guideline, and that's to keep unit interfaces small.